you know, we had some questions about, I had some questions after class last time, so, and then I realized that we didn't take time to talk about the homework assignment that was due last time, so I thought you guys could have an extra day so that we could have some time today to talk about the homework assignment, which we failed to do last time in class. So, are there any questions? Which assignment is this now? Assignment 17. So, and I think this was a couple of exercises from the from our binary text, right? Principles of concurrent programming. And so, and I think were there like 2 questions and one of them had like 5 parts or something like that?
Yeah.
So, and what it's asking you to do is to analyze these algorithms and determine, I think in the one case it was to determine if the program would terminate. Or was that for both of them? Remind me here what those 2 exercises were.
The last 2 exercises?
The 2 weren't there 2 written ones? Oh, okay. What was the first one?
The first exercise is the one that has 5 parts, and you basically
it's asking
if they are correct for all scenarios, and if not, then give a counterexample.
Okay, if they're correct for all scenarios, and then otherwise give a counterexample. Okay, now let's talk about that one. What's the number on that?
It's exercise 2.5.
2.5. So this is binary. Exercise 2.5. And this has the 5 parts to it. Was it like algorithm A, B, C, D, E, something like that? Okay, so does anybody have any specific questions about that we can clear up, that we can answer? Yes. I thought we were going to have some questions here.
Did you just go through like how deadlock?
Oh, the question is, yeah, that's a good question. So the question is, one of them mentioned the word deadlock. Actually, I'll tell you what let's do. In order to mention the word deadlock, let's take a look at wasn't there in algorithms D and E, isn't there like an await statement? I think let's talk about the await statement, and then I'll try to explain what deadlock is and how it could occur. Now, so let's do algorithm D. Let's talk about algorithm D. Algorithm D in exercise 2.5 of binary. Now, tell me, which P statement had the await? P, P2. So here, tell me what is in this exercise. There's a P2 colon, and then what did P2 say? What is it? Just tell me what it says. Await.
Turn equals 1.
Await. Turn equals 1.
Turn gets 2.
And then it said turn gets 2. Okay, so here, let's see what this means. First of all, notice that this is not P2 and then P3. This is not P3. Are you with me? This is part of P2. And what was our assumption in binary? What is every statement? What is our atomic statement in binary? All the exercises in binary. All the algorithms in binary. What is that they are what? That they are atomic. So what we need when we analyze the interleavings, it's impossible to interleave between this and this. Okay? Because this whole thing is atomic. It happens indivisible. It's indivisible with liberty and justice for all. All right? Now, what in fact does it do? So suppose that we have like, suppose that we are in a state, in a scenario, and there's some other instruction and suppose that we have two possibilities. Suppose we have P2 and some other statement from Q. So I'm going to say Q, I'm just going to say QX. All right? This is some other statement from Q. Are you with me? So let's suppose that we are in a state where either this one could happen next or this one could happen next. Is everybody clear? Okay. Suppose we're in this state. Now here's the point. Here's the point. If in this state, if turn equals 2 in this state, then you cannot pick P2. That's what this means. To execute next. Is everybody with me? Here, let's say turn equals 2. So this represents the state of a state transition diagram, and we have to choose either between P2 or Q something. And what we're saying is that if turn equals 2, you cannot, you're prevented from picking P2. You have to pick the QX. You have to pick the other one. That's what this await statement means. Are you with me? On the other hand, if you are in a state where we have P2 and QX and turn equals 1, if you ever have a state like this in your scenario, then what can happen is, because P2 says await turn equals 1, in this particular state, you can either pick P2 or you can pick QX. But furthermore, if you pick P2 in this state, make sure we get this on the camera. If you pick P2 in this state, then what will the next state be? Well, what's the one that comes after P2? So here, if you pick P2 to execute, then what will the state be? Is that the one that comes after it? Is it P3? P3 would be the one that would be ready, and QX would be the same QX. But now what would happen? Instead of turn being 1 here, because if you pick P2, it awaits turn 1, and atomically what does it do? It sets turn to 2. So, oh wait, this isn't equals, isn't this gets? Yeah, this should be left arrow. Is everybody with me on that? That's, yeah, a little momentary lapse into Java there. Okay, and this is turn, and so what? And this is turn equals 2. So this, are you with me on that? So that's how this await statement works. It's atomic. And so now your other question though, so this is how the await statement, your other question is, what is this idea called deadlock? We're going to investigate this in a lot of detail, what deadlock is. So this is our introduction to the concept of deadlock. Let me just write down, can we focus over here? Let me just write down what deadlock is. Deadlock is when a concurrent programming is when a concurrent program is waiting for an event that will never occur. It's when a concurrent program is waiting for an event that will never occur. And colloquially speaking, this is what happens when your system freezes up. Freeze up. Not F-R-E-E-S, F-R-E-Z-E. It's when it freezes. You see what I mean? You know, and what happens, you know, if in a severe case when your computer freezes, what do you have to do? Yeah, you have to hard restart. You have to intervene. You have to intervene to get it to hard to. So, or it's when an app freezes up. You know how like, and if an app freezes up, what do you have to do? Force quit. Yeah? So that's the phenomenon of a deadlock, force quit. Now let's come back to here and let's see how could a deadlock occur here? How would it be possible for a deadlock to occur with these await statements? Well, one process might be doing an await, and the other process might be doing an await, and they might be stuck there, both of them waiting for an event that would never occur. And if you analyze, so here's your hint, if you analyze the algorithms in here, one of these, if you do the interleaving correctly, you should be able to come up with a scenario in which case, boom, it's stuck. Yeah? Do you see, does that help? Kind of? Well, we just need to analyze all those interleavings and consider what can happen here, right? And by the way, this turn is a shared variable, right? So this turn, so they both have access to turn.
For this assignment with the algorithm, should we make the assumption that they're at least somewhat fair?
Oh, now there's, the question is, what assumptions do we make on fairness? And if you go to the assignment specification, not in the book, but online, there is some specific, in fact, why don't we read that for me?
In the cases that are incorrect, let's state the zero.
Yeah, but I think there's some,
Assume weakly fair scenarios for algorithm 0A and 0B.
So,
do not for 0C.
So for A and B, assume weakly fair, and for C, don't assume weakly fair.
Okay.
Well, what about D and E?
D and E, you have no choice? Oh, because of the awaits.
Mm-hmm.
Yeah. Okay, I think this is everybody, does this help clarify, how, you know, how you have to analyze this? Okay, we're not going to go through and actually do the homework. I mean, I'm not, but does everybody see what's at stake? I mean, what the issues are that you need to analyze for this, for these interleavings? Are we good? And then I think, and then what was the other one? Was it 2.5 and 2.6?
Oh, it was 2.9.
Oh, 2.9?
9 and 10.
Oh, 9 and 10. Oh, there were 3 exercises. Okay, and then was 9 the one to show that, or to?
It had like, it showed one algorithm and it had 4 parts, and it just says, construct a scenario for which a program terminates, what possible values of n
Oh.
there, and then does it
That's-
terminate for all scenarios and for all fair scenarios?
All fair scenarios, okay. So then we define fair scenario.
On
What-
2.5,
Mm-hmm.
if we do find one that's correct, do you have to explain why it's correct, or can you just be like,
That's a good question.
Exhausted all of my
Yeah, you don't need to prove that it's correct if you find one that's correct. It's, you know, this is like those prove that or determine whether an argument is valid, and if it's not valid, find a counterexample, and if it is valid, prove that it's a theorem. Remember how we did those problems in formal methods? Well, this is like that, isn't it? You're trying to find a counterexample to show that it's incorrect. And if you can't find one, it's another thing to prove. And actually, we're going to talk about we're going to do some proofs. So we'll save the proofs for later. Did it ask you to prove that it was correct, or did it just determine it?
It just said,
well, it's
it says show that it is correct.
Show that it's correct. Well, yeah, fine. Yeah, you can just maybe use a few English words, you know. I tried to find a counterexample, but obviously this will, whatever. Okay, are we good? Does this help? Mm-hmm. Good. And yeah, a lot of these concepts that we're bringing here, we're going to examine in more detail in the next chapter, actually. This whole concept of deadlock, it's one of the important things that we have to look for when we analyze concurrent programs. All right, now, at the end of class last time, we got about halfway through this example 81, And then I kind of like ran out of time in the middle. And so it wasn't too satisfactory of an ending for a lecture. But anyway, so we're going to pick up where we left off. So let's take a look. Actually, let's recall this try-catch. So here's a try-catch with no finally. And remember what we said was, if there are no exceptions in this try block, which consists of the statements A, B, C, D, then what happens is the sequence of execution that happens is first A executes, then statement B, then statement C, then statement D. And if there are no exceptions, we skip the catch and we just go on. On the other hand, if an exception happens at B, then we have what's called this, what did we call that? Abrupt something? What did we call that? Do you remember the phrase we used? Abrupt termination, is that what it was? The enclosing block statement terminates abruptly. Okay, so it was that was an abrupt termination. So what happens is there's an abrupt termination at the statement that causes the exception, and then if we decide down here, if the programmer decides to do some processing, if that kind of an exception happens, then what the programmer does is he says catch, and he puts the type of the exception here that he wants to catch, and then a variable, which is that exception that he can use then in these lines in F and G. So this is kind of like a parameter. So it's kind of like this. It's kind of like this little function gets called, you know, and X is the object, is the exception object that we can use to process, to handle whatever we want to do at F and G. So in this particular case, the sequence would be A, B, the exception happens, and then F, G, and then we go on. That's with no finally. All right, and then what we said is we were going to illustrate this with example 81, and last time we already looked at the details of this weekday exception, which is an exception that's created by the programmer, and we saw how there is this super is a call to the constructor of the exception, and what it does is it concatenates this string to the toString whenever we output the exception, okay? And then what we did is, and here's where we terminated abruptly. Yuck, yuck. in the middle of the class, because we had an exception caused by the time, by the clock. Okay, so we had to terminate abruptly, and we didn't really take a look at this code we looked at the exception code, but we didn't look at the code that causes the exception. So let's do a little code walkthrough here of Sestoft example 81. So here is the code from example 81 in Sestoft, and let's take a look at what the main program does. First of all, the main program uses, it's going to use these command line arguments. And what does he have? In the main program, he has try, and then there's just one statement in the try block. And what is it? What kind of statement is it? System.out.println. Now, what's he going to print line? Arg sub 0. Now, what is this arg sub 0? That's the first command line argument. You remember that? Okay, so that the command line argument, quote, is a weekday number. Are you with me? And then he's going to concatenate that with what? wday number 4, and he's going to pass that string to wday number 4. So what is this wday number 4? That is this method, static int wday number 4, right? So it's going to print out an integer. And I think actually, probably, I'll tell you what let's do. At this point, I think it would be good to run the program and see how wday number 4 works with no exceptional event happening. And I think we actually did that at the end of class last time. But let's do it again. So here comes our demo. Now, we are going to have to go. Okay, so here's our example. Here's our demo. And this is take 3 of our demo. And what we're going to do is we CD into our example 81, and then we CD into build. And we CD into classes. And let me see, if we ls example 81, yeah, and here we are in example 81, right? And so now what do? We do Java, and then example 81 dot example 81, right? And now what we're going to put on the command line is Wednesday. Now watch what happens. What does it say? Wednesday is what? Weekday number 3. So let's go back to the code and see why it does that. All right, so here we are back to the code. Now check it out. So when we typed in Wednesday, it did system.out.println Wednesday, so arg sub 0 is the string Wednesday. Are you with me? It's Wednesday, and then it concatenated is weekday number, and then it called wday number 4 with Wednesday. So now it jumps down to this wday number 4, and notice what this does. This returns an int. And which int did it return? What did it say? It's number 3. Okay, so that was the int that it returned, yeah? Okay, so how did it do that? What did it do? Well, first of all, it says what might happen if something goes wrong is this might throw a weekday exception. Okay, that's what this phrase means, right? But wday is Wednesday, all right? And now what does it do here? It does for int I gets 0, I less than wdays dot length I plus plus. Now what the heck is wdays? Wdays is an array. And what array is it? It's this static final string wdays. And because it has string square bracket down here, what does that mean? It's a what? An array of strings. And so what strings are in there? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So wdays sub 0 is Monday. Oh, he starts, this is very European. You notice? European calendars, you know that? European calendars start out on Monday, US calendars start on Sunday. Okay, so anyway, so Monday, Tuesday, so 0, yeah, so actually, so the array is, this is sub 0, sub 1, sub 2, right? So Wednesday is sub 2. So what he does here is he goes through here in a loop, and he says, if wday equals wdays sub I, and it doesn't equal Monday or Tuesday, so it equals wdays sub I when I is 2, so he returns I plus 1. Now because he returns I plus 1 right here, what does not happen? What does not happen? Throw new weekday exception with wday. Do you see what I mean? Because he returned right there. So do you see that that was a normal return? And furthermore, what happened to these catches? Because there was no exception there. What happens to those catches? They don't get executed. And we just went on and we terminated. Now, did you see how that illustrates the flow of control with an exception? Well, that illustrates the flow of control in a try when there is no exception. But now how can we, but now, what's another way to test this? Let's do it, let's demo it with example 81 with WED XXX. Now let's go to the code and see if we can predict. What will happen if we do with XXX? It'll be for int I get 0, I less than wdays, but then what will happen? We won't do the return, right? So then what will happen here? Throw what? New weekday exception wday. But now, so what will happen? The exception will happen right here. So it will do what? What is that called? It will terminate abruptly. It will terminate abruptly. And we'll go down these list of exceptions. Now, which one, what is this throwing? A weekday exception. So which one will get caught? The first one, right? We'll do catch weekday exception X. So now what is X? That is an object. That's a variable of type weekday exception. And what does this catch do? System.out.println, weekday problem, and then what is this X? What gets printed out with this X? Well, that's the toString, right? It's the toString for that X. But what did we see that it did? It concatenated that phrase. So let's demo that. Okay, so we're back to demo mode. Let's go back to our terminal. And this time, instead of saying example 81 Wednesday, let's do example 81 XXX. Okay, are you ready for this? Drum roll. All right, here we go. Boom. And what did it say? Example 81, weekday exception, illegal weekday, Wednesday, XXX. Right? Okay? So, and why did it say illegal weekday, XXX? Because that's this super call. Illegal weekday plus W day. All right? Now, okay, so, and one more demo of this. Let's do example, let's do example 81, but now what are we going to do? Type in nothing. Now, can you guess what's going to happen here? If we type in nothing, what's going to happen here? What kind of an exception will happen here? It'll be, what's going to be the problem? When we say system.out.println and then we do arg sub 0, what's the problem? There is no arg sub 0. But is this going to be a weekday exception problem? Yes or no? Is a weekday exception? No, because we didn't even get to here to be able to throw that. But there will be an exception which will probably get caught what? Here, and so what will come out? Other problem. See, and with X. Okay, so here let's try that. So back to our demo mode. So here we are, and now here we go. Boom. 81, example 81, with no arguments. Ooh. In fact, that happened to be an index out of bounds. Yeah. So that one's built in. Remember we said that array out of bounds are built in to Java arrays. Does everybody see how that worked? All right. So, and then this also illustrated throws. If a method is capable of causing an exception that it does not handle, it must specify this behavior so that the caller of the method can guard themselves against that exception. And you do this by including a throws clause in the method's declaration. And so that's what this was. It throws weekday. This is the throws clause, okay, that was included in this WD number 4. All right. So now the next one. This is an example that's not in Sestoff. This is an example that's in that I created to show how the exceptions propagate up the call chain. Now, tell me, what happens when a function gets called? What gets allocated on the runtime stack? Yeah, a stack frame, also called an allocation record. And what all is in there? The return address, parameters, local variables. You guys have all done these before, right? Okay. Return value if it's a non-void. And then if that function calls another function, what happens? Another one gets on top of that, and then another one on top of that. And if it's recursive, then all those copies get all. Are you right? So that's the call chain. Okay? That's the call chain. One function calls another one, calls another one. Each time it gets called, there's stuff gets allocated on the runtime stack. So that's called the call chain. So now what happens is, if suppose a function calls a function which calls a function, and then an exception happens in that one that gets called. Well, what happens when an exception occurs? what do we call it, abrupt? But if a function that got called by another abruptly terminates, what does it have to go back to? It has to go back to the what? To the function that did what? That called it. But then, now the exception is there. But now what happens if that one doesn't catch the exception? It goes to the one that called it. So that's what we mean by uncaught exceptions propagate up the call chain. So let's take a look. So we're going to demo this next one, this exception review, with a 10 and a -10. But let's take a look at the code. So myException.java is going to extend a runtime exception. Here's the version number, and is all we're going to do is here's the constructor for myException, and is all we're going to do is just call the super message. We're not going to pin anything to it. Okay. And so here is the main program for exceptionreview.java. So check it out. Here we have public static void main, and we're going to call it with a 10, right? And so here int x gets integer parseInt, because the 10 is a string. All these arguments are all string arguments. So to turn it into an integer, we have to parse it. And so x is now an integer 10. And now what's this going to do? It's going to say system.out.println main started with x equals 10, right? And then we have another little local variable here called x2. And we're going to do try x2 gets top x. Well, what is top? What is top? Top is this static int top. So x is going to correspond to y, right? And x is going to be 10, right? And so we're going to go to top. And now what's top going to do? It's going to say top started with y equals 10. And then what's it going to do? Int y2 gets bottom y. So then bottom is going to call what? Oh, here's this one calling bottom. And so y is 10. So now z is going to be 10. And this throws my exception. So look what happens here. Bottom started with z equals what? 10. Now what's it going to say? Now what is this statement? This is just a nonsense program. If 10 is less than 0, is 10 less than 0? No. So it's not going to throw an exception. It's going to do what? Bottom returning 20, and then what's it going to do? Return 20. So the 20 is going to come back up to here, and then what will y2 be? 20. And then it's going to say top returning y2 equals 20. And then it's going to return y2 to 20. And then that's going to come up to here, right? And then x2 is going to be what? 20. And it's going to say main ending with x2 equals 20. And there is no exception, right? So that's just normal because we didn't catch. Is everybody with me? Okay, so let's try it. Now, so this is exception review. Okay, so back to demo mode. And we want to do exception review. So let's cd to exception review, and then we cd. Oh, this looks a little different. Did I compile this? Maybe, hold on. So let's do build. Oh, maybe it wasn't built yet. Let's do a new ls. See where we are. Oh, we hadn't built it yet. Now we have. Did you guys see that? Build and cd into classes. Is that where we go? Yes. And if we do ls exception review, there is our exception review class. So now we do Java. And we don't put the dot class. So does everybody see how to do command line arguments here? Okay, so now what do we say? 10? So here comes the demo. Check it out. Main started with x equals 10. Top started with y equals 10. Bottom started with z equals 10. Bottom returning 20. Top returning y2 equals 20. Main ending with x2 equals 20. No problemo, huh? No exception. Whoops, let's go back to our, now let's go back to our code and try to and see what happens if we do this with -10. So now what's going to happen? This x2, if we do it with -10, then this will be -10. This will call x2 top. Top will call system dot started with -10, and we'll come down to here, system dot out, blah, blah, blah. Bottom started with z equals what? -10. But then what's going to happen? It's going to throw my exception, throwing my exception. So now, is it going to say bottom returning 20? No. What's it going to do? It's going to go back to top, right? But now what do you suppose is going to happen at top? Because where did the exception occur in top? Right here. Okay, so what do you suppose it's going to do? Do you suppose it's going to say top returning? Probably not. It's probably going to come and be propagated up the call chain. Do you see what I mean? And then what's going to happen here? When we did x2 equals top 10, well now we're going to catch my exception, and it's going to say what? Caught an exception, E, and then we're going to say x2 gets 99, and it's going to say print out main ending with what? 99. All right, so let's check it out. I think this is a really nice little visualization of how that propagates up the call chain. Is everybody ready for this? Here we go. -10. Main started with -10. Top started with -10. Bottom started with z is -10. But then what? Caught an exception. Exception review dot my exception. Throwing my exception. Main ended with x2 equals 99. So that's how it propagates up the call chain, abruptly terminating each function that called it. Okay? And now here's what happens, you guys. Frequently what happens is, so if you write a program where you don't catch any exceptions, where there's no catch phrases, and if an exception occurs, what will happen is it will propagate all the way up the call chain, and then your Java program will terminate with an error message. And have you experienced that before? So that's what, you see, you can prevent your thing from terminating if you catch the exceptions that you want to catch. And you can control what happens. But if you don't control anything and it propagates all the way up the call chain till it gets to main, then it will terminate with some Java system error message that has to do with the exception. Does everybody see how that works? Are we good with this? And now, you guys, comes one of the best examples in the history of Java examples, I think. This is a very clever example. Now watch this. It's example 90. And this example is so well crafted that I want you to exercise it, and I'll tell you ahead of time that this is going to be a question that's going to be on the final, on the exam. I'm going to give you this example 90 code and a command line input, and you need to be able to understand how try, catch, finally works to be able to predict what the output is. So let's just go ahead and note this right away. It's a very clever example that can exercise all possible flows of control through the try, catch, finally statement. And if you want a detailed explanation, it's on section 12.6.6 on page 56. And there is a key sentence that is about the finally clause. But I think before we actually try to read that key sentence, I think what we should do is I want to demo the use of this. Let's take a look at we'll take a look at the code, and I want to demo it, and then we won't have time to do the whole thing. So we are going to, again, terminate abruptly in the middle of this example and take it up next time. But it won't be quite as abrupt as last lecture. Now, check this out. First of all, the try, catch, finally statement has try, and then body, and then catch, and then catch, and then catch body, catch E2, catch body. Now what we're going to do is we're going to investigate what happens if there is a finally clause. So now we have finally and a finally body. And now let's, before we take a look at how finally works, I want to at least, before class ends, demo this so that we can see what it looks like. Now check it out. This documentation section of Sestoft says how to use this program, this example. He says, to exercise all paths through the try-catch finally statement in method M, run this program with each of these arguments. 101, 102, 103, 201, 202, 203, 301, 302, 303, 411, 412, 413, 429, 433. Like this. Java, example 90, 101. Java, example 90, 102. Java, example 90, 103, etc. So what he has done is he has written this really slick method called M. It's just a one-letter method that illustrates the flow of control through the try-catch statement. So let's take a look at the main program. When we first execute example 90, what does it do? It says if args.length is not equal to 1, then it prints out an error message. So it makes sure that we have one argument. All right? And let's suppose that the argument is 101. Then it does what? It does system.out.println M. Now what is this M? That's a method that's on the next slide. Right? And what do we give M? What does M take as a parameter? It takes % of the number that we typed in. So is everybody with me? M is a method that he wrote that takes an integer. Now let's take a look at the structure of M. Here is the code for M. Now obviously you don't have to memorize, you don't have to like reproduce M. I will give you the M, and what you need to do is be able to trace through it and predict what the output is. So let's take a look at the very first, let's just take a look at one, let's run through this and assume that we have actually entered a 101. Actually, I'll tell you what let's do. Let's demo that. Let's demo this with 101. Let's check this out. CD ... CD ... Oh, we need to do it again. I forgot how many times we had to do this. And that's example 90. So let's CD to example 90. Oh, this one looks like it hasn't been. Oh, I know why it hasn't been built. This is a new computer. Yeah. Example 90. So I'm having to build these. Yesterday. Yeah. Did that do 90? Did that build? I didn't see that. Okay, well, we'll build it again. Oh yeah, it did build. Okay, so let me see, go back to the terminal. Okay, so now if we do ls, see, now there's a build. Okay, so let's cd to build and cd to classes. And now if we do ls example 90, what's in there is the example90.class, which is our program. So now that we're in example 90, which is, by the way, that's the package name. Do you remember package, the concept of a package in Java? We mentioned that very briefly. So let's do Java example 90, and we're going to do a 101, 101. Now watch what happens. Try ... finally terminated normally with 101. So that was the output. Now let's go and see if we can see why that happened, how that happened. Now watch how this method M works. Int A, so what is the value of A? It's 101 in this example that we just did, right? So it's going to say try system.print try ... Now do you remember how it did try ... when we just did the demo? And now what's it going to do? If A divided by 100 equals 2, return from try. If A divided by 100 equals 3, throw new exception thrown by try. If A divided by 100 equals 4, throw blah, blah, blah. Now what number did we enter? 101. So what is 101 divided by 100? It's 1. If we had entered 201, then 100 divided by 1 would have been 2, right? But what we entered was 101. So does A divided by 100, does that equal 2? Yes or no? No. Then does it equal 3? No. So does it equal 4? No. So what happened? Didn't do this, didn't do this, didn't do this. And so what about this catch? Nothing happens here. What about this finally? Well, yeah, it runs. Finally always runs. Yeah, we're going to talk about that tomorrow or next time. Finally always runs. But what happened when we got in here? Did it say finally? Did it?
Yeah.
Let's check that. Yes, it did say finally. See right there? Okay. So it ran and it did system.out.println. So even though it skipped the catch, it didn't skip the finally. So system.out.println finally. And now what is a mod 10? What does mod mean? Remainder when you divide by 10. So what is 101 mod 10? 101 mod 10 is what? Is 1. That's the last one. That's the last digit, right? And now, so A mod 10 equals 2, yes or no? A mod 10 equals 3, yes or no? So none of this stuff happens. And what happens? Did it say terminated normally with 101? Did it say that? Let's double check that. Yes, terminated normally with 101. So now do you see how we analyzed you see how this example worked with 101. Now, on the other hand, if the 3-digit number started with 2, then what would happen? It would say system.out.print try, but then what would happen? It would do what? Return from try. Then something else would happen. And if the number that we entered started with a 3, what would happen? It would throw an exception within the try. Do you see what I mean? And if the number that we entered started with 4, what would happen? It would throw new runtime exception thrown by try. Exception, this is a runtime exception, right? Is everybody with me on that? Okay? And on the other hand, what happens when we're in the middle? In the catch, what does the code do inside the catch? It does system.out.print catch ... But now, what is if we had entered 200 and I don't know 20 what's in yeah 203. Well, he's got here a 203, right? A 203. So what would happen at a 203? So now what is A divided by 10 mod 10? So which digit is that? Well, A divided by 10 is the what? The first 2 digits, and then mod that by 10, and you get what? The middle digit, right? So if the middle digit equals 2, we do this. If the middle digit equals 3, we do this. Well, that is a very good question. The question is, won't that only happen under certain circumstances? And what we're going to do is, what we're going to investigate tomorrow is we're going to see see what happens in those specific cases. We're not going to have time to run through all of them, but we're going to run through enough of them to get a flavor of what the deal is. Did you have a question?
Yeah, I was going to ask, so like at the top if it's A divided by 100 equals 3, and it throws a new exception, but it doesn't catch an exception?
Yeah, all of...
Does it just terminate?
That is a very good question. The question is what happens under that particular scenario for a particular number, which was started with a 3. And the answer is, we're going to look at that in detail on Thursday. And that's the kind of thing that you need to know how it works. I want you to know, you need to understand how the try, catch, finally statement works. And here's why. Because in Java, you remember how we did the try, join? All that has to happen in a try. Okay? And so, yeah, and so we need, what we want to do is, our objective here is to understand exactly how the exception handling happens in Java. All right? Good deal. See you Thursday.